So I add the first reagent and take the second reagent and so with adding the buffer, phosphate buffer. So we add the test samples. So this one, I'll face it into the carton. I'll take the initial reading at 0. 1.83. 1.03. Yeah, this is still okay, it's increasing. But we're having a different test now. So there may be some peculiarity with that group. And this CDMB, I'm also suspecting something that the concentration may actually be increasing with time due to evaporation of the ethanol.
The concentration of the CDMB?
Yeah, no, because of the ethanol. No, it's a mixture of ethanol, CDM dissolved in ethanol, so there may actually be some increment, but provided there is still increase in this one, it's okay. So anytime we are having ethanol in mixture now, we have to increase the volume at least. We have to double it or we triple it. And we give room for the volatility of it. So that's in case it evaporates, we know we still have a volume that will still be enough for it. So we are checking the wavelength at 60 second interval. So we have the 0 from 0 to 60 seconds, from 60 seconds to 120, from 120 to 180. So our calculation will now be based on the difference in the initial readings and the final reading. So we are now on the last one now. There's still increment, right? Okay, so on this particular assay, we are looking at the concentration against the absorbance. So we'll be considering that using a standard curve that has already been predetermined before. Then we look at that after the initial calculation. We check the average and we see. Yeah, all right now. So we look at it to check for any outliners. So outliners are the extreme values. So if we look at the extreme values and the extreme values are not so much, then we can now make do with the mean. We calculate the mean, we look at the standard deviation, then we compute our biostatistics. Okay, so this 1200. 1200. That's the last one, right? Okay, so at the end of the first interval now, which is 180, that is approximately 3 minutes. We change it, then we turn the quartz progress downwards to drain out the remnants of the analyte that has been used from the first sample. Then we get the first reagent ready. For this, for example, I'm using 150 microliters. So I add 150 microliter of the first reagent to it. Now I add the GSH reagent, the second reagent. Reduce reduction. Then we add the buffer, phosphate buffer to it. Then we add the test sample last as the last that will be added to this composition. Then we have it inverted this way and now inserted. Ensure the cursor is handled. So we fit it into the cradle and we start the reading at 0. So we have 864 as the initial from here. 864 at 0 seconds. Then the timer will help us with the interval. So we'll be able to know when we are having the 60, the first 60, then the second 60, the third 60. So meaning from 0 to 60 seconds, from 60 seconds to 120 seconds, from 120 seconds to 180 seconds. So that's what we're looking at. Then we must also be able to have our predetermined values, as in what our expectation is. Our expectation is that the numbers here, the absorbance from the analytes should be increasing. So if it's contrary, then we know that something is wrong somewhere. Then we look at the reagents, then we look at the compositions of what we have. Already we have our spectrophotometer ready, which is from the sample. So 960. So we have the spectrophotometer ready. So we know our spectrophotometer is not the faulty one, it will be the reagent. So we have to look at the reagent and check if the buffer, for example, where we are using buffer, we check if the buffer is actually well calibrated, because the buffer is calibrated. Like the buffer I'm using faucet buffer, which is calibrated at 6.5, a pH of 6.5. So if it's showing otherwise, then it means we have to look at it very well and adjust it to know whether the issue is from the buffer. Or otherwise, we look at the glutathione, the reduced glutathione, and see if our composition also is okay. Then, if that is also fixed, then we can also look at the other one, which is the CDMB, 1-chloro-2,4 dinitrobenzene. So if we look at the dinitrobenzene and look at it to know if it's actually the 1044. So then we can now retry it again, but ensure that before starting it, we have to do the blank. For this one now, we do the blank with an empty cuvette. Then we now run the blank test. The blank test will be done using, instead of using the sample now as the analyte, we use distilled water as the analyte. So we add all the reagents, then we now use the distilled water. All now depends on the protocol anyway. So your protocol may be different from my protocol. So the protocol I'm having here, I'm using distilled water as the test sample, as the test sample I'm using. Then after that has been run and recorded, we can now start with the main analyte, which is our real test samples. This is the last one. Okay, so that is that. So once this is done, we do this process for all samples. So once it's done, we empty it and we start the process again. Do you get now? So thank you for watching. Like, share and subscribe to our channel. See you in our next video.